All right, we're going to look at U substitution as a technique, but I need to review the chain rule before we do, because U substitution is essentially the integration term for reverse chain rule. So remember, when we differentiate using the chain rule, we recognize that the outer function here is a power function, so we're just going to do power rule. We multiply by 5 and drop the power by 1. But that's not it. The chain rule says that the rate of change of the inside function is going to have an impact on the rate of change of the whole function. So we multiply by the rate of change of the inside. We end up with an expression, or in this case it's an equation, that looks like this, where we have x cubed plus 1 to the 4th, which is a reduced power from before by 1, and then we have an extra 3x squared here that came from the chain. Now, make the observation then, if we're going to reverse the process, if I see an integral that looks like this, then what I have to do is recognize that this was chain ruled. The key is to see the inside function, inside a composite. If I took the derivative of the inside function, I would get the 3x squared. So that's how I know that this was chain ruled, and all we're going to do with U substitution is streamline the process of reverse chain ruling. And you'll see why when we get to the second example. But for starters, we're going to identify the letter U, which is just a generic name for a substitution function. It's kind of a convention that we use the letter U for that. But anyway, we're going to let U equal x cubed plus 1. And therefore, if we take the derivative, we get du dx is equal to 3x squared, which looks very familiar. Now what we can do is just multiply kind of both sides by dx. In other words, we can express 3x squared dx is exactly the same as du. So here's what we do. We spot a 3x squared dx. Here's the 3x squared times dx, and it says right here that 3x squared times dx is equal to du. So I'm going to take these two pieces and say that's du. As a result, now I just integrate u to the 4th power, which is a simple power function integral. It gives me u to the 5th over 5 plus c. But I was not given a function in terms of u. I have to replace it back where I started from. So I said u is the same as 3x squared plus 1. So instead of u to the 5th over 5 plus c, I write 1/5, and then I write x cubed plus 1 to the 5th plus c. Before we look at the last example for this video, I want to point out that the answer, or the integral that I got, 1/5 x cubed plus 1 to the 5th, is not surprisingly the very function that I started with. So you can see by doing your U substitution, and specifically the part where I replace 3x squared dx with the du, you can see how that sort of makes this so that I don't have to think chain rule. It cleans itself up along the way. That's the whole goal here. Now, the reason why we need this mechanism or this technique is because sometimes the derivative of the inside function is not explicitly obvious when we look at it. Take this for example. In this function, I see denominator has x cubed minus 3x. If I took the derivative of that, I would get 3x squared minus 3. The numerator has an x squared, but it's only a negative 1x squared and a positive 1. So the derivative of the more complicated part of this function is not exactly the same as the numerator in this case. But what we can do is make some modifications, scalar multiples, as it were. So for starters, I know that u is going to be the denominator, x cubed minus 3x. Then du is equal to 3x squared minus 3 dx. My reason for multiplying by negative 1/3 is to make the coefficient on x squared negative 1, and consequently would make the coefficient on the constant be 1. So in so doing, I have to multiply both sides of this equality by negative 1/3 so that I can get an expression that I can substitute. So negative x squared plus 1 dx is right here represented as dx 1 minus x squared. All of this stuff here can be replaced by negative du over 3. Bear with me as I extract the 1/3 right away, take that out of the integral so it's not ugly inside, and then I got the 1 over u, and then I've got the du. So remember, du times negative 1/3, du times negative 1/3, I just substituted in here. We know the antiderivative of 1 over u is the natural log of u. So we're going to have negative 1/3 natural log of u, and then I just put the u back as x squared cubed minus 3x, and I have the integral. Now, in this video, I'm not talking about how to check your answers. I'm not talking about, understanding, except to look at the idea that the u sub is just reverse chain rule, and sometimes we need to scale. That's the whole purpose of this video. As for checking your answers, graphical interpretations, definite integrals, and those kinds of things, that's all for other videos, other lessons. But for now, hopefully this is helpful in trying to understand not just how to use the u substitution, but why we invented u substitution. So thanks for watching.